Hello class, welcome to exercise 3F, where we're going to learn all about negative indices. Negative indices may already be obvious to some of you after our last lesson. They are an obvious extension of law 2. In this class, the pre-learning and examples are example 14, writing expressions using positive indices. And the pre-learning for you in this example is questions 1 and 2 in the new book and questions 4 in the old. Then we'll be doing example 15, which is using index laws with negative indices. And your pre-learning for this example is question 3 in the new book and question 5 in the old book. And then finally we'll do example 16, which is simplifying more complex expressions, where your pre-learning will be questions 4 and 6 in the new book and questions 6 and 8 in the old book. This video will be a lot quicker than the last one, simply because it's just an extension of what we learned in that video. Alright, I'll see you in the introduction. As we've already mentioned, this lesson is really just an extension of our last lesson, but we do have a few more considerations to take. Okay, to begin exploring these negative indices, let's consider a to the 0 divided by a to the m. Now the second index law says that that's equal to a to the 0 over a to the m, or a to the 0 minus m. And 0 minus m is equal to negative m, so that's actually equal to a to the minus m. This means that a to the minus m is equal to a to the 0 over a to the m, and a to the 0 divided by a to the m. And in the last lesson we also learned that a to the 0 is equal to 1, providing a is not equal to 0. Then as a to the minus m equals a to the 0 over a to the m, because a to the 0 is actually equal to 1, this means that a to the minus m is actually equal to 1 over a to the m. This is the definition of a negative indice. So let's do a little numeric example, because if the numbers work, that'll help us with the algebra a lot more. So if we imagined 2 to the minus 3, now by our negative index laws, we would say that 2 to the minus 3 is equal to 1 over 2 to the 3. And 2 to the 3 is equal to 8, so 2 to the minus 3 is equal to 1/8. If we were to use these numbers to test index law 1, and let's remember that 2 to the 5 equals 32. So we want 2 to the 5 times 2 to the minus 3 to equal 2 to the 2. If we sub in the values we know that these numbers are, is 32 multiplied by 1/8 equal to 4? Well, that's just 32 divided by 8, and that is equal to 4. So index law 1 does work with negative indexes. It's nice to know that we haven't broken maths yet. But of course we're going to keep trying that, right? Another thing to remember is that if I have 1 over a to the minus m, well that's the same as saying 1 divided by a to the minus m. And we've already established that a to the minus m is equal to 1 over a to the m. That equals 1 divided by 1 over a to the m, just by what we've established earlier. We also know that dividing by a fraction is the same as multiplying the reciprocal, so now it's actually equal to 1 times a to the m divided by 1. See, important facts from a past unit does help you in this unit, so of course that's going to continue on. Can you just give me a second to figure out what multiplied by 1 and divide by? That's equal to a to the m. So this means we now have two important facts that is worth writing down again. Firstly, a to the minus m is equal to a to the 1 over m. And secondly, 1 divided by a to the minus m is equal to a to the m. Hopefully this tells you that a to the minus m is really just the reciprocal of a to the m. With an actual numeric example, 3 to the minus 1 is 1 over 3. Or just in case the powers are still a little confusing to you, 3 to the minus 2 is 1 over 3 squared. And as we saw in the previous numeric example, negative indexes don't change how index laws 1 and 2 work. In fact, negative indexes don't change how any index laws work. So this means for law 1, a to the m times a to the minus n is equal to a to the m minus n. And also a to the minus m times a to the n equals a to the minus m plus n. And for law 2, a to the m divided by a to the minus n, well, that's equal to a to the m minus n, which is the same as saying a to the m plus n. And for law 3, a raised to the power of m, all raised to the power of minus n, is still equal to the multiplication of these two indexes. So that's going to equal a to to the power of minus mn. And perhaps I don't need to show you this, but it's also true that a to the minus m, all raised to the power of positive n, is equal to a to the minus mn. And I'll just quickly write what law 4 is with negative indices. In just the same way, it should be obvious what happens with law 5 and negative indices. This should be obvious to you because the index laws lead us to add or multiply the powers. You've added and multiplied negative numbers before, so nothing changes in that respect. You've also seen the numeric example why it should work. In this lesson, you're also going to be asked to write expressions using positive indices. That might sound like a silly thing to say when we're learning all about negative indices, but it'll make a lot more sense and it'll be explained in great detail in the next section. It's important that that's in the introduction because it is a take-home skill, so be aware and look out for it in the next section. But having said that, perhaps you want to pause the video now and think about what it might mean to see if you can guess it yourself. And with that, we should finish introduction and move on to that section. In this section, we'll be writing expressions using positive indices. So I've told you about the idea of using positive indices already without explaining them. It does seem weird to have a whole section on positive indices in a lesson all about negative indices. Well, positive indices mean we just have nothing with a negative power. So therefore, a to the minus m should be written as 1 over a to the m. And 1 over a to the minus m should be written as a to the m. So the expressions on the left have negative indices and the ones on the right have positive indices. All right, so keeping that in mind and how to use negative indices in the index laws, let's move on and do example 14, which not very surprisingly is asking us to express the following expressions just using positive indices. Okay, so the expression in part A is b to the minus 4. This won't need any comment at all. By definition, this is equal to 1 over b to the 4. So now we have no negative signs in the index, therefore this is expressed with positive indices. Part B, the expression is 3 times x to the minus 4 times y squared. So as I said in my description of it, that's actually equal to 3 times x to the minus 4 times y squared. Obviously 3 does not have an index with it, y has a positive one, so it stays the same, but x has a negative one, so that becomes 1 over x to the 4. Now we can multiply these things and turn it into one expression. And now we have an expression with no negative indices. All right, in part C, we have the expression 5 over x to the minus 3. You can separate these two and write them out as 5 times 1 over x to the minus 3. And we all know what to do with this 1 over x to the minus 3 now. That just becomes x to the 3. So our final solution is 5 times x to the 3. So hopefully they're nice and easy for you. But to make sure, pause the video now. And if you have the new book, work on questions 1 and 2. And if you have the old book, work on question 4. And I'll see you in the next section. Okay, in this section, we're going to use the index laws with negative indices. So in the last section, I carefully stepped out converting negative indices. But after seeing that and having a go yourself, you should be ready for me to stop over-explaining. So in other words, if we have a negative power on the denominator of a fraction, it'll become a positive one in the numerator, and vice versa. Also, if you're not totally comfortable with the index laws, as well as how they relate to negative indexes, you need to have a copy of them in front of you right now. All right, let's get straight into example 15, where we need to simplify the following expressions. In part A, the expression is 2a cubed b squared over a to the 5 b to the 3. Now we can split this up just like I did in the previous question. So that's going to now equal 2 times both of the a's times both of the b's and raised to the powers that they have. So if we use law 2 now, we can re-express this as 2 times a to the 3 minus 5 times b to the 2 minus 3. And obviously 3 minus 5 is minus 2 and 2 minus 3 is minus 1. So that's now 2 times a to the minus 2 times b to the minus 1. And as a and b are raised to negative indices, to make them positive, we need to put them on the denominator. So now we have 2 divided by a squared times b. Because don't forget, b to the 1 is just b, right? Now before I go on to b, I'm just going to say that there probably was a quicker way of doing that. So let me write out that expression one more time. Right, so we can now recognize we've got a times a times a 3 times. And in the bottom, we've got a times a times a, blah, 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 5 times, right? So if I cancelled out 3 factors of a from both top and bottom, I'd be left with none on the top and 2 on the bottom. And the same goes for b. So we could just cancel these, and by cancelling, one way you could look at it is multiply both top and bottom by a to the negative 3 and b squared. So a cubed times a to the minus 3 becomes a to the naught, which is 1. B squared times b to the minus 2, b to the naught, which is also 1. So we can ignore those. And a to the 5 times a to the minus 3, well, that becomes a to the 2. And b to the 3 times b to the minus 2, well, that becomes b to the 1. So you could easily do this. You could even write it just by cancelling out the indices in the fraction. Anyhow, both methods are fine. As long as you're following logically consistent steps, you'll get to the right answer. All right, let's have a look at part B, where our expression is 4 times m to the minus 2 times n to the 3, all divided by 8 times m to the 5 times n to the minus 4. Okay, so straight away I can cancel 4 out of the top and bottom, so that 4 disappears and the 8 turns to 2. And to make the m to the minus 2 positive, I can just put that on the denominator. And the m to the 5 is positive on the bottom, so I'll leave that there. And the n to the minus 4 on the bottom, well, I can put that as n to the 4 on the top. And the n to the 3, well, that's already positive, so I'll leave that there. Now using law 1, n to the 4 times n to the 3 becomes n to the 7. M to the 2 times m to the 5 becomes m to the 7 as well. So that means I end up with n to the 7 divided by 2 times m to the 7. I really apologise if my m's and n's sound too similar, by the way. I don't think that was too hard, but I don't think it was easy either. But it does definitely get tougher in the next section. So you really need to practice questions at this level before you move on to the next section, all right? So trust me on that. Which makes the perfect segue to saying that you should pause the video now and work on questions 3 if you've got the new book, and questions 5 if you have the old book. And I'll see you in the next section. Okay, in this section, we're going to be simplifying more complex expressions. So in this section, the expressions are as advertised. They can look decidedly beastly. So you can consider this a test of your courage. However, like all large problems, they can get much less complex when you break them up into small parts and methodically solve each part using the rules and the laws we've already learnt. So stick to all the laws we've learnt in the last lesson by making sure you have a copy of them in front of you, including the negative indices laws that we've spoke about today. I know I've got a copy here right now. And also, do not forget BODMAS. And I appreciate I sound a bit like a broken record now, but obviously it's important. Okay, the expression in part A is, and let me take a breath,
p to the minus 2 times q, all raised to the power of 4, divided by 5 times p to the minus 1 times q to the 3, multiplied by p to the minus 2 divided by q cubed, all raised to the power of negative 3.
Goodness me. Okay, so following the steps of BODMAS, I'm going to use index laws 3 and 4, and maybe it's 5 as well. Following the BODMAS rules of using the bracket first, we'll now expand those brackets. So the numerator for the fraction on the left now becomes p to the minus 8 times q to the 4. The denominator in this fraction doesn't change. With the fraction on the right, we raise the numerator and the denominator to the power of minus 3. So now we have p to the minus 2 times minus 3 is 6, q to the minus 9. BODMAS for the brackets, and I've used laws 3, 4, and 5. P to the minus 8 times p to the 6 becomes p to the minus 2, and q stays as q to the 4, and for the denominator, 5 times p to the 1 times q to the minus 6. If I move that q to the minus 6 from the denominator into the numerator, it becomes q to the 6. And if I move the p to the minus 2 from the numerator to the denominator, it becomes p squared. Now you might be asking, why didn't I move the p to the minus 1 to the numerator? Well, I was planning ahead to use index law 1. So p to the 2 times p to the minus 1 is p to the 2 minus 1, which is just p. And at the top, we're going to get q to the 10. So we end up with q to the 10 on 5p. So just to say, I've used index laws 1 in the last step and the third last step. And in the second last step, I converted negative indices to positive. Okay, in part B, we have this huge expression that I'll just write down. Okay, I think you know what I'm going to do next. I'll be using BODMAS to expand those brackets. So multiplying the indices through, that now becomes
2 to the 3 times m to the 9 over r to the 6 times n to the minus 12, and 5 squared times n to the minus 4 times n to the 6, and r squared.
All right, next step is to turn the division into a multiplication of the reciprocal. So let's quickly write that out. And let's evaluate those numerals. So 2 to the 3 is 8 and 5 squared is 25. Next, I'm going to consolidate using law 1. So r squared divided by r to the 6 leaves me an r to the 4 on the bottom. And then I'm going to move the negative indices from the bottom to the top. And consolidating those two m's, I now get 8 times m to the 11 times n to the 6, all divided by 25 times r to the 4. And that's the final answer. I can't simplify that any further. It really was a lot of steps, okay? So please make sure you practice problems just like this. And you can do that by pausing the video. And if you have the new book, do questions 4 and 6. And if you have the old book, do questions 6 and 8. And I'll see you back in the summary. Okay, let's summarize this lesson. To consider this lesson a success, you understand how negative power relates to division. You'll know how to rewrite expressions involving negative indices with positive indices. And you'll be able to apply index laws to expressions involving negative numbers. Many of these questions can just seem like heavy lifting, and it's easy to be turned off maths when you're given a lot of questions with such complicated algebra and there's no sign of how this relates to your life, or there's no way of finding any surprising or interesting results. However, these algebra skills are vital for many of the challenges you will face in the future. For example, I can remember learning about the maths behind quantum mechanics and it involved doing lots of algebra like this. If you can imagine that I was now teaching you how to play guitar, this is like learning all the scales and chords that you need to be able to play any song. Just as it would be frustrating to hear future musical collaborators saying to you, "Oh, this is too complicated for you to play," just enjoy listening to it. You will also find it frustrating in the future if you're going to work on something interesting in science, engineering, or economics, and your colleague says to you, "I won't bore you with the algebra, but we're basically doing blah, 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 whatever it is he's doing." If you're able to master this level of algebra, that will never happen to you. So work hard until you get comfortable at this and recognize where you're finding it tough so you can ask for support. Never be afraid to ask for support. All right, so I'm going to see you in class or the next video. Have a great day.